All right, in this lesson, we're going to focus on how can I find the volume and surface area of a polyhedron, a three-dimensional solid. And there's some important vocabulary. The focus of this is really on our vocabulary here, and we're going to teach everything. We're going to be able to answer most of this question here primarily through teaching the vocabulary, with the exception of surface area. I'm going to kind of leave that one with some hints and see if you can figure out what in the world surface area means and how would you figure that out. The words we would look at would be point, line segment, polygon, congruent, cube, surface area, and volume. So we'll start up here first with point. A point is a location in space. Generally, it's mathematically represented by a little dot, usually labeled with some kind of a letter, generally a capital letter. So this could be point A, and that's a point. A line segment is a line with two endpoints, and I can illustrate that for you simply by drawing a line close to it, or better yet, let's use the shape drawer. And there we go. There's a line for you. And the key thing here is you have two endpoints. One here, one here. This is a line segment, sorry. You might call this A and B. So it's a line with two endpoints, maybe A and B. You might write this A, B, line segment A, B. And the key thing is it also includes all of these points in between. So there's a bunch of there's all these points in between A and B, and those are included in line segment AB. Next, we have a polygon, which is a closed figure formed by three or more line segments. So you would take three or more line segments, and you would put them together to create a polygon. I can show you that by taking some line segments. 1, 2, 3. Now, if you take these and manipulate them around, you can create a polygon. So let's twist these around over here. I can make them longer and shorter, and this should obviously form a triangle. But you notice that, like, if I have these two, I can't really have a closed shape, because when I close it, I'm just overlapping the line, and that creates just a line, not a polygon. So you have to have a closed figure formed by three or more line segments. And there we go. So it takes three of them to close it off. This right here is not a polygon. You have to close it, and you have a polygon. So that right there is a polygon. Another word to understand here is the polyhedron is when you have a three-dimensional figure that's is formed by regular polygons. Specifically, a polyhedron is looking at specifically a polyhedron is any three-dimensional figure formed by polygons. So like if you took a whole bunch of squares, if you took 6 squares and you formed them together, you could make a cube, like this, right? These dots. You have the sides and the back that you can't see. But this is also, since you have a regular polygon, this is what would be called a regular. Regular polyhedron. Just another aside there about what a polyhedron. And that's where congruent gets in terms of being regular. Regular polygons have like the same. They have the same line, all the sides are the same, all the angles are the same. So congruent relates to that. In terms of congruent things that have the same size, shape, and measure. So I talk about two angles, they both have the same measure. If I talk about two triangles, they would have the same size, shape, and measure. A cube, what I just drew up there, is it's a regular polyhedron with 6 faces that are congruent squares. So it's kind of unique in that sense. So basically a regular polyhedron made of squares. The great way to draw a cube is an easy one that I actually know a strategy to draw, is you draw a hexagon, a regular hexagon, as close as you can. You put a dot in the middle, and you connect every other vertex or corner to here, and then you can draw your dotted lines in the back, and you can see your three-dimensional cube there. Surface area. Well, what is a surface? And then what does area mean? I don't know something about areas and surfaces. How would surface area relate to a polyhedron like a cube? Volume, we've discussed, is basically you're going to take the area of the base here, which would be your length times your width. So length times width for the area of the base, and then you have to multiply it by your third dimension, which we call the height. So length times width times height is your volume. So a more mathematical definition of volume might be the amount of space occupied by an object. Yeah, we can calculate it by multiplying our length and width of the base and then multiplying by the height here. However, when we're talking about the amount of space taken up by an object, you can also measure volume. You do this all the time when you're talking about like capacity, when you're measuring with like a beaker or something. If you have a beaker, it looks something like this, right? And over here it has like in milliliters how much liquid is in here. So you might fill up your liquid here and you're kind of like, oh, well, I have this many milliliters. Well, that's exactly the amount of space occupied by an object. It's called your volume. So when you're measuring capacity, you're measuring volume. And say with a cube, it's a little trick to finding volume is that if you know it's a cube, and I told you that this side length was 3, well, that means that if this side length is 3 and this is a square, all the sides are 3, so that makes this 3. And if this is a congruent square, that makes this 3. So all the sides are 3, so it's 3 times 3 times 3, which we call 3 cubed, because it'd be 3 times 3 times 3. Length, width, and height. 3 times 3 times 3 equals 3 cubed, equals 9 times 3 is 27. So that's why they call it cubed. Let's go back here. We should have a better understanding of volume, and based on volume and understanding polyhedrons, how can I find the volume and surface area? That's what you really want to start thinking about. How can you find surface area of a polyhedron? That's what I'll leave you with.